Good day. Good day, grade 12 learners. Welcome to today's Technical Mathematics. My name is Matsidiso Kongwani. This lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center and broadcast by Pakama Research and Development. Okay, grade 12, today we are looking at mensuration and the area of irregular shapes. Without any waste of time, let's start with the business of the day. Our objectives of today's lesson: after the completion of the lesson, you will be able to, number one, convert the units, square units and cubic units. And then secondly, you will be able to calculate the surface area, the volume of right prisms, cylinders, pyramids, cones, spheres, and the combination of everything. And then number three, you will be able to determine the area of an irregular figure using your mid-ordinate rule, grade 12. Those are the three objectives of today's lesson. Okay. And then now, it is very important to know how do you convert your unit, grade 12. Most of the time you will be converting from milliliters to a meter, maybe as a base unit, or from that meter to kilometers. So it can be milligrams or the milliliters or the millimeters. So grade 12, basically what you are going to apply is, if you are converting from a small unit, remember millimeters are smaller than kiloliters, right? So if you are converting from small to big unit, so you must know that you do what? You divide, but whatever, either 10, 100, 1,000, depending on which unit you are converting from, and then to which one are you converting to. And then now let's say you are now moving from what? From the bigger unit. Now look at the bottom one. If you move from big to small now, for each unit you will be multiplying with the 10. This simply means, grade 12, now if I am moving from kiloliters to meters now, kilometers to meters, therefore I will multiply by what? How many times? 1, 2, 3. Therefore this will be multiplied by 1,000. Same way, if I'm moving now from meters to millimeters, because I am moving from big to small, I will be multiplying. And then let's check now. If I move from millimeters to millimeters, how many times I have taken? 1, 2, 3. Therefore this must be multiplied by 1,000, because I have moved 3 times to the left. All right, the same way applies now if I'm moving to millimeters to meter. From millimeters to meters, now I'm moving from small to big. As long as I'm moving from small to big, I must divide by how many times now? 1, 2, 3. Therefore this will be a division of 1,000 from millimeters to meters, grade 12. I hope we are still together. The same applies now if I'm moving from meter to a kilometer. I am moving from small to big, how many times? 10, 10, 3 tens now. Because it is small to big, therefore I will divide by 1,000 again, from meters to kilometers. This basically means what now, grade 12? If I am moving to millimeter now, moving to kilometers. How many times are in between? 1, 2, 3, 4, 5, 6. Small to big, therefore I am dividing by how many times? 6. Therefore it will be 1, 2, 3. How many? 6 zeros, grade 12. I hope this is clear now to everyone. Small to big, you divide, and then big to small, you multiply. All right. And then let's look at the activity whereby now we are converting units and square unit and cube unit now. Our first activity here, it states that convert the following numbers into required units. The first activity there, we are converting 1,000 meters to kilometers. How are we moving now? Small to big. Okay. So if it is small to big, from meters to kilometers, remember the meter is in the middle, and then you are moving to your far right, grade 12 as we indicated previously. Therefore, if it is small to big, that means we are dividing by how much? By 1,000 now in this case. So what you'll simply do is you are going to take the 1,000 meter, divide it by 1,000 to move it to kilometers. And then this will be equal to what now? 1 kilometer. Therefore, 1,000 meters is equal to 1 kilometer, grade 12. I hope that is clear. Okay, is the application of what we did previously in our explanation. And then number 2, we are moving now 1 square meter to a millimeter squared. Okay, look at that. There's a mistake there. It is 1 square meter to a millimeter squared. Okay, grade 12. Then if we look at the previous table that we were using, we were not working with squares now. So if you want to move from the previous table to squares, you always start from the beginning. Now, in the table, we are having what? The conversion of a meter to millimeters. Okay, and then that is indicating that what now? If I am having 1 meter, this will be equal to how many? 1,000 millimeters, because I am moving now from what? From big to small. And then if we move from big to small, we do what? We multiply. So we have multiplied 1 meter with 1,000. That is why we have 1,000 millimeters. All right, grade 12. And then from there now, we want to relate this to what is given to us as a question there. In our question, we have to look at 1 square meter now. Let's see what is happening. Okay, on the side where we are having meters now, we are going to look at 1 square meter. How can 1 meter be squared? It's when you square the whole thing. Okay, the same will be applied to the right hand side now. This will be equal to the 1,000 millimeters. We are also going to square the right hand side and see. Let's see what do we end up with. We have 1 square meters equal to 1,000 square will give us now what? 1 million with 6 zeros. And then now this will be in millimeter squared, grade 12. That is how you find 1 square meter into millimeter square. Okay, 1 square meter will be 1 million millimeter squares. Okay, moving on to the third question now. We are having what? A 1 centimeter cubed. We are converting this to millimeter cubed, cubic millimeters. All right, 1 cubic centimeter to cubic millimeters. Let's see now, how do we do this one? We always start from the beginning now. Remember, when you compare centimeter and millimeter, we are moving from big to small again. Remember, millimeters are smaller than centimeters. So we are moving big to small. The minute we move big to small, we do what? We multiply. But remember, centimeters are so near to each other, so you only apply a tenth, 1/10, okay? Therefore, we start now. Okay, 1 centimeter will be to 10 millimeters. But in this case, we are looking at the cubic centimeters, not a centimeter, right? So to get a cubic centimeter, we are going to cube each side now. Okay, cubed that side. We also add the cube to the right-hand side. Let's see what will be the final answer now, grade 12. It will be 1 cubic centimeter, which is equal to, you start by cubing a 10. 10 to the power 3 is equal to 1,000. Okay, it's 1 with 3 zeros, and therefore it will be in cubic millimeters. Therefore, we have now arrived to our answer. A 1 cubic centimeter is equal to 1,000 cubic millimeters, grade 12. I hope we are still together. Let's look at number 4 now. In number 4, they say express the mixture of 250 milligrams per 50 milliliters. This must be milliliters. And then we are changing that into grams per liter. Okay, so we are having two conditions, grade 12, whereby the first condition, you are changing the 250 milligrams to what? To grams. The second condition is where you are changing what? A 50 milliliter to what? 2 liters, so that it can give you the ratio that is given to you, which is grams per liter. All right, let's continue now doing so, grade 12. We are having 250 milligrams, and then we are moving from milligrams to grams now. That is from small to big. And then from small to big, remember, you are dividing by what now? By 1,000. Okay, so if we divide 250 by 1,000, we end up with what? With 0.25. This will now be in grams, grade 12. I hope we are still together. Our milligrams is now in grams. Then we deal with the part where we are having 50 milliliters. So we are changing milliliters to liters now. If we move from small to big, grade 12, we now divide by 1,000. Let's continue now. 50 milliliters. Still dividing by 1,000, and then this will give us how much? The 0.05 liters. Happy now, grade 12. This is now in grams and liters. And then let's write in a correct notation now. Remember, initially they were saying convert 250 milligrams over the 50 milliliters into the grams now and per liter now. So the milligrams to grams is 0.25 grams divided by the liters, which is 0.05 liter. This is now in grams per liter, grade 12. And then if we simplify this now, it is giving us only what? A 5. That is 0.25 divided by 0.05. It is giving us 5 grams per liter. I think we have now arrived into our answer, grade 12. Those are the basic conversions, grade 12. Remember, small to bigger, you are dividing. From big to small, you are multiplying. That is the application around it. Okay, so you need those conversion of unit, number 1. And then number 2, you need to know your formulae. How do you calculate the area? How do you calculate the volume? How do you calculate the perimeter, the surface area of particular prisms? Okay, now let's look at the first one now. Before we start with mensuration, we need those formulae, grade 12. Our first shape here, we are having a rectangular prism When you talk of rectangular prism, we are talking of a box. It can be either rectangular or a square box, grade 12, but the application for both is the same. So now you must be able to give us a net diagram for that particular rectangular prism or a square prism that will be given to you. Now, if you unfold this box, remember it will be having this front part with the one that is having at the back, which is exactly similar to that one. And then it will be having the top part here and the one that is below or the underneath part. So this is exactly the same. The top and the bottom one there, they are exactly the same. And then the front and the back one is exactly the same. And then we'll have the left and right part of the box. So basically here we are having 6 sides of the box. And then 2 are similar, 2 similar, 2 similar, exactly the same. Okay, grade 12, then we will be having those 3 groups now with similar 2 same here, 2 same, and the 2 parts same there. And then let's look now when we draw a net diagram. This will be your first part, which is the left hand side one, and then this will be your right part. Okay, and then this will be the top. Remember, we have removed the top part here, and then this will go with the bottom part there. They are exactly the same. Okay, and then we have the front part, which goes with the back part of your box. Then we have unfolded this particular box and formed a net diagram. And then now, what do you use to calculate the area? What is the formula for the area of the prism now? This net diagram will assist you in finding that area, which we call the surface area, which is the total area of the particular prism. Okay, and then what is the surface area formula for this? Remember, we have 2 parts which are exactly the same. The left and the right part of the box is exactly the same. Therefore, we'll be having the first 2 length by breadth, which is representing the left and right. Okay, and then plus we are now adding maybe the top and the bottom. That will be 2 breadth by height, and then plus the last part, the another 2, which will be 2 length by height. So we have now represented all the pairs that we have in that particular diagram, grade 12. Okay, and then now if we look at the volume of that particular box, this one I know most of us, we are familiar with. The volume of a box is length times breadth times height of the particular box. Okay, so this is for the rectangular prism or a square prism. They are both acting the same. And then let's look at the cylinder now. When we refer to a cylinder, we are talking to a glass. We are talking to a can of Coke, and then those round figures, containers, then we refer to them as cylinders. And then they are having the top part is either open if it's a glass, and then if it's a can, it will be closed on both bottom and the lower part of the container. And then we call them the cylinders. Now with the cylinder, we have the height of the cylinder there, and then we have the radius of the cylinder. And then when we go to the net diagram of that, it's like you are cutting one side of that cylinder. You put a scissor somewhere here, and then you cut that part. And then when you cut, it will be unfolded and form something like this particular rectangle that you are having at the center. And then the circles, the top part and the lower part, it will now be dismantled and form those 2 circles that you see on the diagram, which is for the top and the bottom part of your container. This is particular what we have as our net diagram. Okay, grade 12. Then it will still take the radius of the container. Initially, that was indicated there, and then the height here will still take the height of the container as it was indicated there. Okay, and then now let's talk to this side now. How are we going to find the dimension of that? part now. Remember, that was created by the part that was forming the circumference of that particular container now. If you cut it here, it will be unfolded and form something straight like that one. It's like grade 12 when you are having a round cylinder like that. Look at this, I am demonstrating to you. Then I am cutting one part from this side here. And then look at this, I'm having two circles there. That is the top and the bottom part. And then if I cut this cylinder, then it will unfold and form a flat surface like that one. Then it's like we are having a rectangle now, which is length by the breadth. But look at the top part here. It is the part that came from your circumference there, from your container where you were having a circumference. And then if we unfold that, that means this part will be taking what? The formula for the circumference of the circle. So that means this one will be the 2 pi r part of your circle. Okay, and then now let's elaborate on the formula for that particular area cylinder. Then this will be 2 pi r squared. Why 2 pi r? Remember, the area of the circle is pi r squared. Since we are having 2, the first one and the second, then will be 2 pi r squared for those circles. Okay, and then this will be added to the area of this rectangle now that we are having at the center there. And remember, the area of a rectangle is length by breadth. And then what is our length? What is our breadth? We are having the breadth, that the length, that is 2 pi r, remember, which is the circumference of the circle of which the side is formed from. And then this will be multiplied by the height, which is this side here. Then that is why it's saying 2 pi r from that circumference, and then with the height of the container. That is the formula for the area of the cylinder. And then for the volume of the cylinder now, remember, we are talking the inside of the container now. Volume, we are talking the inner part. And then that will take now the area of the base. Our base, remember, is the circle. That will be pi r squared. And then that will be multiplied by the height to be a volume now. We are adding one dimension there, which is the height of the container. Is the area of the base. Since our base is the circle is pi r squared, then we multiply by the height of the container, grade 12. Okay. And then now the formula of the cone, and then the net shape of the cone. Look at that. It's like now we are cutting off one part of the cone there. If I am cutting this cone throughout here, then I will be having a circle, which is the part that is closing the cone. And then now it will form something that is opening a gap like that one here. It's not a full circle, grade 12. Look at that. This is the part that is missing there, which is forming the shape of the cone there. That is the net diagram for that. And then how do we find the area of a cone now? The area of a cone is pi r squared, which is representing this part. Okay, the pi r squared. And then plus the pi. Okay, the area that is pi r l. Okay, now let's address this. Is pi r squared, the radius will still be the radius that will be given to you or originally from your cone then. And then it will be the same for this r and also that r. Okay, and then now pi, remember, is on your calculator. Don't stress about that one. And then the length, we are talking from that point to that point. That means it's referring only to the length of the cone now. So you can also take it from that point to that one. Okay, we are talking to the length of the cone. Okay, and then the volume of a cone, grade 12, we are talking to 1/3, which is pi r squared, and the height of the cone there. Okay, and then now the area of the sphere, the net diagram of a sphere, the volume of a sphere. And then if you look at sphere, is something like a ball, grade 12, or a tennis ball. And then now, how do you go with the net of that one? You will be having a hemisphere if it is half like that one. And then here we have illustrated now. If you are having a tennis ball and then you are cutting, you'll be having something that is forming something like circles like that, okay? Those are the net diagrams of a sphere. And then how do we go about the area of that? That will be 4 pi r squared, okay? And then with the volume, we are having 4/3, and then that is pi r cubed. Okay, grade 12. Let me go back to the cone again. Let me clarify one thing. When we are referring to the height here, we are referring to the height of the cone that will be indicated there, okay? And then this L now is different from that particular height. Sorry for that confusion, grade 12. That L is indicating the slant height. We call it the slant height. What do we refer to when we talk to slant height? That is the height that we are talking for, that is slanted, because this will form a 90 degrees triangle there. Therefore, there will also be an application of the Pythagoras theorem to calculate the slant height, grade 12. But you'll see thoroughly when we are doing examples around that application. Lastly, grade 12 in formulas, we are looking at the formula of the pyramid now. And then the pyramid, it depends on the base, whether your base is a square base, we are talking to this part, or the lower part of your pyramid there. So this base can either be a square, a rectangle, and so forth. And then now, with the pyramid, when we form a net, we just cut off these triangles on the side. We are having 4 sides with 4 triangles around the pyramid. We have a base there, and then it's holding those 4 triangles from 4 sides of your base. And then if we cut off those sides, they will form triangles, as you see in the diagram. Since the base is a 4-sided figure, therefore that is why we are having 4 triangles around that particular pyramid. And then how do we calculate the area of a pyramid? We take the area of a base. If a base is a rectangle, that means it will be LB, length by breadth. If it's a square, it will be square, S squared for the sides. And then plus you add the sum of the areas of the triangles that you have on your sides there. So that will be basically 4 equal sides, and then for this particular diagram, and then you look at the area of a triangle, which is half base times the perpendicular height. And then if your base is a rectangle, it will basically be length by breadth for the area of a base, plus the 4 triangles around the diagram, and then the sum of its area, which will be half pH. Okay, right. And then the volume now. With the volume, the formula is 1/3, and then multiply by the area of a base, and then we multiply by the height of the pyramid. Okay, and then that is 1/3 of the area. Remember, I've already talked to the base. It can be a rectangular base or a square base. It depends on the pyramid that is given to you. So we are applying that, grade 12. Okay, and then let's look at the worked example there. We are given to work out calculate the volume of the box. Let's look at the box. The first thing that you need to do, grade 12, is to look into the diagram. Are your dimensions in the same unit? That is the first thing. Yes, okay, they are all in centimeters. Happy now. We can now start looking at the questions. Calculate the volume of a box. If you look at the volume of a box, remember we have indicated that it will be LBH, right? What is the length? 22. Substitute breadth 8, and then we have 43. And then if you multiply them out, grade 12, I hope you also have your calculator with you. This will give us 7,568 cubic centimeters, because our dimensions are in centimeters. I hope we are still together, grade 12. We now look at the surface area. Remember, we have already elaborated that we have front, back, top, bottom, left, right. So it will be double LH, double LB, double BH, okay? Okay, we are looking at the surface area of this particular shape. It will be 2 times, let's see now. Let's break this out. Okay, if we take left and right, it will be 2 times the block for left and right. And left and right is having with dimensions, that is 22 multiplied by 8. We are talking to that side or this one. They act the same, okay? They are 22 by 8. And then another one. Let's talk to front and back now. If we look at the front rectangle and back, this one is having, we are talking to this one, grade 12 is having dimension 43 on the longer side, 43, multiply by this dimension of 22 here. That means we are having a 43 by 22. Our last pair, we are talking top, bottom now. It is still a rectangle, okay? And then if you look at top, we are talking 43 times 8 now. It acts the same as the bottom one. So it will be 43 by 8. So we have now analyzed our diagram. We can now put it on our calculation. That will be 2 of what? 8 times 22 for 2 rectangles. Plus, we take the second one now. It will be 2 times 22 by 43. And then another 2 by 8 and 43 grade 12s. I know our calculator can put everything into that calculator. Stop simplifying partially, because somewhere, somehow you do mistakes, grade 12. Your calculator can accommodate all these brackets, and then it will give us an answer which is 2932 squared centimeters. Remember now the difference, the volume we are using cubic centimeters. For the area, we are using the unit square centimeters. Your surface area, everything to do with area, it will always be squared. Everything to do with volume, because it's a 3-dimensional, it will be cubed. All right. And then lastly, grade 12, let's convert our answers now. 1.3 says convert the answer in 1.1. What is the answer in 1.1? 1.1 is 7,568 cubic centimeters. And then the answer in 1.2, we are having what? The 2932 square centimeters. And then they say now convert these answers respectively. So the first one you are converting to, this one you convert to cubic meters. It is missing from our question there. And the second one we are converting to square meters, grade 12. That is our conversion. Let's continue now. Remember, centimeter to meters, we are moving to small to bigger now. But remember, you are not moving from millimeters. It won't be 1,000, because you move from centimeters to meters. It will be divided by 100 instead of 1,000 now. Divide by 100. Divide by 100. This will basically give us how much? This will be 75,68 cubic, okay, cubic meters, grade 12, not centimeters, cubic meters. And then we have taken this from 7,568 cubic centimeters. Okay, this is in cubic meters. And then let's look at the second one now. We are converting centimeter squared to square meters. Moving from centimeter to meters is 100, not 1,000, because we are not moving from millimeters now. Okay, now from centimeters, same application, we divide by 100 now, because it's centimeter to meters. And then this will give us how much now? This is giving us the 29,32 square meters. That means this square meters is equal to the 2932 what? Square centimeters. They are exactly equal, grade 12. I hope everything is clear now. Okay. And then now, without any waste of time, I want you to work out the activity 1, where we consider the prism below. We are given the prism 70 millimeters, 100 millimeters, 200. You are calculating the volume and the surface area for this particular prism, grade 12. Your 5 minutes start now. Okay, grade 12. Let's see now how far did you go with the solution. All right. Okay, you remember the tip that I gave you, that you talk to left, right, you talk to top, bottom, you talk from front and back. All right. We are now calculating the volume. With the volume, there is no much challenge like when calculating the surface area. With the volume, you just stick to your formula. You know that the formula for the volume of a box is V equal to the L length breadth by height, LBH. We are more used to that one. And then now we can now substitute our values. Remember, you verify first, everything is in the same units. Okay. Okay. Covered now, everything is in millimeters. And then now let's substitute. We are having 200 multiplied by 100 multiplied by a 70 there. And then you just put everything into your calculator, grade 12. This is giving you 1,400,000. That is 1,400,000 cubic millimeters. And then let's say now the question was calculate the volume of the box, and then leave your answer in cubic meters now, not millimeters. So if you are changing this to cubic meters, remember you are moving to millimeters to meters now, then we are dividing by 1,000. That means you'll be dividing this with 1,000. Then this will give us how much? The 1,400 cubic meters is exactly equal to that one. And then when coming to allocation of marks, grade 12, you'll be given a mark for selecting the correct formula. The second mark will be for substitution. The third mark will be for the answer. Then if you are asked to give it in cubic meters, therefore you will also be awarded the mark for changing that into cubic meters. So basically with this will worth 3 or 4 marks depending on the phrasing of the question. And then let's move on. 1.2. We are looking at the surface area now. Remember, with the surface, we are going to have the surface area, which is 2 left and right. Okay, left and right. Let's look at one that we have 100 by 70. Okay, a second one, we are looking front and back. And then if you look at front and back, we are looking at 200. This is the dimension for front. And then for the height here, we are having 70. Okay, it is taking the same height, 70, 70, 70, around this. Okay, and then plus the 2. And then we are now talking to the top and bottom. And then for the top, this 200 is 200 throughout for all the sides. So now this is 100. It is taking 100 and 100 to that side. Can you see that it is moving around like that? Okay. Now, for the last dimension, it will be 2 times the 200 for the top, multiply by 100. So grade 12, you put that into your calculator. This will give you that what? An 82,000 square millimeters. Remember, volume is cubic, and then the area is a square unit. And then now, if maybe you are asked to give this question in square meters, not in square millimeters, the same way you move to millimeters to meters now, and then it's small to big, therefore you divide by 1,000. So this will basically give us what? An 82 square meters. That will be the surface area for that. Okay. All right, grade 12. There we have another activity. And then let's take another 5 minutes for you to go through that activity. Try this one and be careful in this case, grade 12. You are given the volume. You are calculating the value of X. The X is missing there. And then you calculate the surface area of a box. Start by calculating the value of X. And then number 2, you now calculate the surface area of that particular. You are given the volume of a box being 182. Your 5 minutes start now, grade 12. Let's do it. 5 minutes. Okay, grade 12. Let's come back now. I hope you have managed to went through both solutions. Let's see now how far did you go. All right, and then now we look at the question. The volume of a box is given to you. That means you are given LBH, right? The starting point is the given information. The volume of the box is 182. Then you have to determine the value of X. How do you do that? You use the volume that is given to you with the formula. We know that it was formed by the formula LBH. And then now let's do the substituting part. The volume is what? 182. In this case, we are given the volume. We are not calculating the volume, but given the volume. And then now we look at the length of the box. We are having the 4, and then we have the 7 there, and then we have the X. Those are the dimensions, 4, 7, X. It doesn't matter how you put them, grade 12s, they will still give you, even if you can say 7, 4, X, even you can say X, 4, 7, it will still give you the correct answer. All right, and then now we have 182. On the left, we are multiplying 4 and 7, which will give us a 28 with an X, that is 28X. And then to get the value of X, we divide both sides by 28. Therefore, X will be how much? The 6,5. Then you can now put in your unit. So the X value here is equal to 6,5 meters. And then now grade 12, the first mark will be for substituting in the correct formula and the simplifying. Therefore, that question will worth 2 marks. Okay. And then now calculate the surface area of this particular box. We follow the same method. We said the surface area is equal to 2 times left and right. Look at that. We are having 4 by 6,5. That will be 4 by 6,5, which is representing 2 sides. Okay, plus 2 sides. Again, we are taking the front and the back, and then the front we are having 7. Remember, this is taking the same 4. Okay, it will be 2 into 7 into 4, plus the last 2, we are taking the top and the bottom. And then if you look at the top, it is taking this 7, which is 7, 7 there. And then this side will take the 6,5 from there. 6,5 will go there and there. Okay, so this side will also be 6,5 meters. All right. And then now when you look at the top, we are looking at the dimensions of 2 boxes, which is 7 by 6,5. And then grade 12 into your calculators, straight to the answer. Therefore, this is giving us 199 what? Square meters, because we are looking at the area. The unit will be square in square meter. Okay, right, move on. I think now we have done enough of the box and the rectangular prisms. Okay, let's move on to the next shape now. We are talking to the cylinder now. A cylinder, remember, we talked to a can of Coke, a tank, we talked to the glass of water, and so forth. Right. The first example, we are looking at the cylindrical industrial storage tank, those big tanks that we found in industries. And then this container is without a lid, it's open. That means it is an open container on top. And it has dimensions as indicated on the diagram. Our dimension is 15 meters. It's a very big container, which is 15 meters, the height of the container. And then it is 350 wide, 50 centimeters. Remember, grade 12, I've indicated to you that it is very important that you check your units before you start calculating. If you look at this container now, it is having different units. The height is in meters, and then the other dimension is in centimeters. There's no way you can calculate with these units being like that. You need to change one unit, either the meters or the centimeters, depending on what you need to change there. Let's say now we are changing this centimeters into meters so that we can have the same units in our dimension. So we are changing what? The 350 centimeters, we need to change this into what? Into meters. Again, we are moving from small to bigger, but now we are not starting from millimeters, we are starting from centimeters. Therefore, it will be divided by 100, not 1,000. It will be 1,000 if we start from millimeters. In this case, it's from centimeters to meters now. It will be divided by 100. So we are going to take 350, divide it by 100, then it will give us an answer which is equal to how much? Grade 12. That will be 3,5 meters. That means the 350 centimeters is equal to 3,5. So instead of using the 350 centimeters, we will be working with 3,5 meters for that dimension. Then after converting everything and having the same units, we can now attempt the questions. And then the first one, 1.1, they say calculate the volume of the tank. And then remember the tank is in cylindrical shape. And then now the volume of a cylinder, remember it is taking the area of a base. Our base here, you can see that it's a circle. It will be pi r squared. And then with the height of the container, which is equal to 15 in this case. And then now let's substitute. Now we have pi and then our radius, again grade 12. Remember this 3,5 is for the diameters from this point to that point, which is the diameter now. That means this is d equal to 3,5. But if you look at the formula is looking for the radius, not the diameter. So to find the radius, you are going to take the diameter and divide it by 2. Therefore, this will be 3,5 divided by 2, and therefore it will give us how much? The 3,5 divided by 2. That will give us 1,75. So we will be working with 1,75 meters for the radius. Okay, we can now substitute radius is 1,75 and this is squared. And then what is our height now? Our height is 15 meters. Everything is now in meters, grade 12. And then now we are now going to put everything into our calculator. We are having a pi, and then this is multiplied by a pi multiplied by 1,75, and then that is squared multiplied by 15, grade 12. So this is giving us, in terms of pi, our answer will be the 735 over 15 pi. If the examiners, they leave the answer in terms of pi, that is over 16, not 15, grade 12, 735 over 16 pi. And then if they say maybe round your answer to 2 decimal place, you will be continuing pressing an SD button in your calculator. Therefore, this will give this in decimal, which will be 144,32 to the second decimal place. Remember your units, you are looking at the volume, and then this was in meters. Therefore, a volume is a cubic dimension. Therefore, it will be a cubic meters. Okay.
In order.
Okay.
Disappeared. I think it disappeared.
Okay. Okay, grade 12. Let's continue from where we left. We were looking at 1.1 solution is 144,32 cubic meters because we were looking at the volume of a tank. And then 1.2, you were supposed to calculate the surface area of that particular tank, okay? And then now the surface area of a cylinder, the formula that we are using from the table of formulas, grade 12 formulas will be given to you. Don't stress about them. Yours, you must be able to select the correct one. That will be pi r squared. Remember, we have illustrated on this at the beginning where I was unfolding the cylinder, showing you where all these parts come from. And then we have the pi r squared. This is not taking a 2. Remember, if we draw a net diagram for this one, it will be that rectangular part when you cut off one side here. And then it will show a circle, only one for the bottom part. The top part, which is the lid, because it is without the lid, we will never have another circle for the top part. Hence, we are having the area of only one circle, which is pi r squared, the grade 12. I hope we are clear on that one. But in the case where there's a lid, we are going to have a 2 here, which is indicating that we are having 2 circles. So in this case, we have only one for the bottom part, okay? And then now, with the length by breadth, and then what is the length of this particular? We are having the height, which is 15. And then remember, the breadth part is the one that is taking the circumference of the cylinder, which is 2 pi r. It's using the circumference formula, which is 2 pi r. And then from here now, we can now substitute grade 12. And then we are having the pi. What is the radius? We have already calculated that as 1,75. And then this is squared plus 15 for the height of the container. We have 2, we have pi, and then with the radius of 1,75. And then grade 12, you can put everything into your calculator as it is. Do not forget the square, the 1,75. And then if you put this into your calculator now, you will say shift pi button into the 1,75 squared, and then plus 15 bracket 2, and then shift button pi. You close and open the bracket with 1,75. And then this will give you an answer that is 889 over 16 pi. If the examiner say leave your answer in terms of pi. If they say round off to 2 decimals, you press your SD button, then this will go straight to decimal, which is equals to 174,55. And then let's check the units now. We are talking to area, and then everything is in meters. This will be square meters. That is the area of that particular container, surface area, the net diagram of that particular container. Okay. And then grade 12, let me give you 5 minutes to calculate this one. This one is a closed container. Remember now, there is no indication that it is without a lid or it's an open container. So this one is having 2 circles, the bottom and the top part. And then it's a can of Coke, for example, can of a cold drink. And then it's a can that has a radius of 4 centimeters. The radius is given as 4. And then we are given the height, which is equal to 6 centimeters. Yours is to calculate the volume. Remember the volume of a can. The formula is pi r squared h grade 12. And then the surface area of a can, we are having 2 pi. Surface area is equal to 2 pi r squared plus the 2 pi r for the circumference, and then multiply by the height of the container. Your 3 minutes starts now, grade 12. Yours is just to substitute because formulas will always be given to you. 3 minutes starting now. Okay, grade 12, let's check how far did you go with this one. Number one, we check the units. Are they the same? Yes, everything is in centimeters. We are happy covered now. And then remember, formulas will be given to you. So the volume of a cylinder is pi r squared h. And then now yours is just to substitute. We have pi. What is the radius? It is 4 centimeters. But remember, this is squared. And then what is the height of a container? This is equal to 6. And then you just put everything into your calculator. If it is in terms of pi, it will be 96 pi. I hope we are still together. And then if you are rounding off to 2 decimal places, this will be 301,59 in cubic centimeters, because we are looking at the volume. Mark allocation will be for substitution, for selecting the correct formulas, because they will be given in a tabular form. Yours is to select the correct one that you're going to use for the particular question. So it will be the selection of the correct formula, for substitution, and for the answer. Therefore, this will worth 3 marks. If you have to change it to cubic centimeters, then it will be in cubic centimeters in decimal form. Then there will be an extra mark for writing that in a decimal form. And then with the surface area, grade 12, the formula again is 2 pi r squared plus the 2 pi r with the height of the container. And then let's substitute now. We are having 2. We have a pi. What is the radius? The radius is 4. Then we just substitute the radius 4. And remember, this radius is squared now. Plus the 2 pi. And then the radius again, there it appears again. We substitute with the 4. And the height of the container, we substitute a 6 from the given height then. And then everything into our calculators. Our calculator will give this answer in terms of a pi. Okay, that will be 80 pi. And then now if you have to round out to 2 decimal places, you just press an SD button. Therefore, this will give us what? A 251,33. That will be in square centimeters, because we are looking at the area, grade 12. I hope we are still together. Okay, and then let's move to another shape. We are looking at the cone now. And then with the cone, remember again, formulas will be given to you, grade 12. In this case, we are given a cone with a volume of 6,45. The volume is given to us. 6,45 square centimeters there. And then with the height of 40 millimeters. Look at the units now. This is having different units. Okay, that means we need to change now. Let's take a 40 millimeter and change it to centimeters now. We are moving to millimeters to centimeters. Remember, they are neighbors. It's from millimeters, you move straight to centimeters. It's only 1/10. Okay, the movement is from millimeter, which is smaller than centimeter. You are moving from small to big. Therefore, the minute is small to big, we are dividing. So we are going to divide this by 10. 40 divided by 10, then it will give us a 4 centimeter. Happy now. Everything is now in centimeters. Right. Now determine the radius of the cone. It's only then that we can start answering your questions after having the same units, grade 12. Determine the radius of the cone. And then now, how do you determine the radius? It depends on what is given to you. In this case, we are given the volume. Okay, therefore, we are going to use that volume of a cone, which is equal to formula pi r squared h. Okay, sorry. The volume of a cone, and no, this one is for the cylinder. The volume of a cone, grade 12, ensure that you choose the correct one. The volume of a cone is equal to 1/3. Sorry for that particular mistake, which is pi r squared h. Okay, be careful, grade 12. It looks the same as that one of, look at this. It has a part of a cylinder somewhere there. Don't be confused about that one. Okay, and then now we are going to substitute the volume, which is 6,45 in this case, and then it's equal to 1/3. Pi is there, and then we need this radius now, which is r. Remember, we are looking for the radius, we are looking for r. Then I am going to shift r to the side and substitute the h value. What is our h value then? The height of the container is equal to 4 in centimeters. And then now I am bringing again the r squared. I have shifted the r squared because we are looking for that r. And then from here, we can now divide both sides, grade 12. So we have divide by 1 over 3 pi into 4. And then the same applies 1 over 3 pi into 4 there. Then this will cancel the 1 3 pi 4. We are left with r squared. And remember, grade 12 now, in order to find the r now, let's continue this side. And then this will be the 6 comma 4 5 over 4 times 1/3 will be 4 over 3 pi. And then if this side loses an exponent 2 there, this will gain it as the square root this side. So we will be left with only r on the right hand side. And then we can now put everything into the calculator, grade 12. If you lose exponent 2 here, you gain it as the square root on the other side. Hence, we have r is equal to the square root of 6, 46 over 4 over 3 pi. Into your calculator, therefore, r will be equal to the 1,24. And then this will be in centimeters. That will be our radius, grade 12. Then we can plug in into the diagram there. The height is equal to 4. And then the radius is 1,24. And then remember this height, grade 12, it is always a perpendicular height. It goes straight to the center of the circle then. And then now to calculate the surface area of a cone. Remember the formula for the surface area of a cone is equal to pi rs. Remember, this s is the slant height, okay? It's not the height of the cone. It is the slant height, which is this side here, okay? Plus pi r squared, okay? And then now we cannot calculate this surface area because we do not have the value for the slant height. That is our starting point, grade 12. We must calculate that slant height. And then to calculate the slant height, we are using this triangle of 90 degrees here. Using what? Pythagoras. The minute you have a 90 degrees, you can apply Pythagoras. And then let's calculate the slant height, grade 12 then. That is the hypotenuse side according to Pythagoras. So we know that it will be s squared equal to the 2 side, which is height squared, plus the radius squared. That is the Pythagoras theorem. And then to get an s, this side will lose an exponent, then this will gain a square root sign. And then let's substitute. What is our height? Height is 4. This will be squared plus the radius of what? 1,24 from our calculation above. And then this is also squared. So if we put this into our calculator, grade 12, we end up with a slant height of 4,19 centimeters. Therefore, that is the height of that particular slant height, which is 4,19. And then we move back to the surface area now. And then let's substitute into surface area. We have pi. What is the radius? 1,24. What is our slant height? 4,19 plus the pi radius again 1,24. But be careful now, this radius is now squared, grade 12. And then now into our calculator, straight to the answer. This is giving us 21,15 in square centimeters. Then the mark allocation for the first one. Remember, we are using the volume of a cone. Then the first mark will be for substituting the volume into the correct formula. Number 2 for simplification and for finding the R value. So this question will worth 3 marks. And then now for 1.2, number 1 is for finding the S, the slant height. Okay, therefore it will be for using Pythagoras and for finding the value of that slant height. And then now for choosing the correct surface area formula, for substituting into the formula or for the answer. Therefore, this will worth a total of 5 marks, grade 12. Let's continue now. Okay, there you have a cone again. A base of a cone has a diameter of 28. That is the diameter from this point to that one, which is 28 meters. And then we have a height. This is our height, which is 48. Remember, this is D equal to 28 diameter. And then we have a slant height, S is equal to 50 meters then. And then we have to calculate the volume of the cone. Okay, grade 12, remember the volume of the cone is calculated by the formula what? 1/3 of what? Pi r squared h. Okay, that is 1/3 of a pi. Do you see that? We need a radius, but here we are given the diameter. So to find the radius, we take the diameter, we divide it by 2. What is the diameter? Diameter is 28 divided by 2. Therefore, our radius will be 14 meters. So we are substituting 14 for radius there. And then this is the squared dimension. Then h is equals to 48. Grade 12, be careful. Do not mix the height and the slant height. Okay? The slant height is the side that we call it an hypotenuse side in Pythagoras 90 degrees triangle. Right, back to the volume. Put everything into your calculator, grade 12, and then this will give us how much? The 9216 in terms of pi. But if we write this in decimal SD button, this will give us 28,952,91. And then this will be in cubic meters because we are calculating the volume and our unit is in meters. Okay, I hope we are still together, grade 12. And then now with the surface area of the cone, surface area, we are looking to pi r with the slant height plus the pi r squared. Do we have a slant height? Happy enough, in this case, we do have it given to us as being a 50. If it's not given, you use Pythagoras theorem in that particular triangle to find the slant height. Let's substitute then grade 12. We have pi. What is the radius? We have just calculated being 14. And then our slant height is 50 plus the pi. What is the radius? 14. And then this particular radius, it is now squared. And then into our calculator, straight to the answer. And then this will give us the surface area, which is 100 pi in terms of pi. And then if it is asked in decimals, then round off to 2 decimal, it will give us 314. You just press your SD button in your calculator, and then this will be in, sorry, grade 12. The answer for this is 1776 pi, and then the final answer will be 5579,47. This will be in square meters. You can also put units there if you are asked to leave your answer in meters, but if you have to round it off to 2 decimal places, that will be 5579,47 square meters, grade 12. I hope we are still together. Right, the next shape, remember we looked at the rectangular prism, we looked at the cone, we are looking at the sphere now, grade 12. We are looking at the sphere now. Okay, now that is the third shape that we are looking at under the mensuration. And let's look at this one now. We are given a sphere which has a radius of 5 units. That is 5. That means from center to that part, this is 5 units. And then now they say calculate the volume of the sphere. Remember, formulas will be given to you. Yours is to select the correct one. What is the formula for the volume of the sphere? That is equal to 4/3 pi r cubed now. Okay. And then now, as you can see, it needs only the radius to be able to calculate that. And then now we do have a radius, yes, which is equals to 5. That is 4/3 pi, and the radius of 5. Remember the cube now because this dimension is cubed. And then from there now into your calculators, this will give you 500/3 pi. And then if you are rounding off, your answer will be 523, to the second decimal. This was 59999. Rounding off to the decimal place, it will be 60 now. Okay, and then this, because units are not given to us, we'll still write it as unit cubed, because we are not given any particular unit for this diagram. And then number 2, we are looking at the surface area now, grade 12, of a sphere. Let's see now, how does the sphere act now? The formula for the surface area of a sphere, it will be equal to the 4 pi r squared. Okay, 4 pi r squared. Still, it is only using the radius. That means with a sphere, you are only depending on the radius of that particular sphere. We are talking to a tennis ball, we talk to a ball, soccer ball, and so forth. And then that is 4 pi. And then what is the radius of that particular sphere? That is 5, but this one is now squared. And then now our answer into our calculator will give us 100 pi. And then if we have to round it to second decimal, this will be 314. You just press your SD button and then it will give you in decimal form. 314,16. Because you are not given any unit, we'll write it as unit. Since it's an area, it will be a squared unit. Okay. Grade 12, that is how we calculate basically the sphere. And then now let's move on to the pyramid. That is the fourth shape of a pyramid. And then from the pyramid now, right, to find the volume, okay, the time is against us, grade 12. I think we can move on to the mid-ordinate now. And then with the mid-ordinate calculation, grade 12, the irregular shapes. And then let's move a little bit back and look at the formula for this one. Okay, back again. With the irregular shapes, grade 12, this is a very simple activity. Can you take me to the beginning of irregular shapes where we have the formulas? It's so difficult for me. There's a slide missing.
Believe in yourself. Believe a little more in yourself, because to those that believe, nothing is impossible. You have done this before. You have passed your tests before. You have went into a higher grade before. It is possible because you have done it before. Do not doubt yourself. Keep believing in yourself. Keep pushing, because this can be done and you can be great. You have been given power to decide whether you want good results in your life, in your schoolwork, or you want bad results. As Tony Robbins said, it is in the moment of your decision that your destiny is shaped. And your destiny is shaped right now with the decisions that you are currently making in your schoolwork. So decide whether you want to be an A student and start working on it, because there is power inside of you. The infinite power is inside of you, and the time you decide to tap in that power, you will become who you want to become in your schoolwork.
2, 1, your life.
Do you know that you are different? Do you know that your fingerprint is different? It's different from your peers, from the people that you are studying with. So do not compare yourself with your peers. Do not compare your results with what they're getting, because you are different. You have your own talents and skills, and also you have your own gifts. Embrace what you can do. Always put in the work to make sure that your results become better than what they were yesterday. But do not compare yourself, because when you compare yourself, you do not know what another person has, and they do not have what you have. So believe in yourself. You are different, and keep on putting the work.
Okay, grade 12, we are back. Sorry for the disruption. Let's go back to the rectangular prism now. We are taking an example now where you are having different dimensions now. Look at that. We have 3 dimensions, but look at the units also. You are having millimeters and centimeters there. Remember, it is very important that you look at your units before you do any calculations, right? Now we look at calculate the volume of the sugar box. You are having a container of a box. You go to a shop, you buy this container, and it is having these particular dimensions. And then they say now calculate the volume of that sugar box now in cubic centimeters. All right, grade 12. And then since the shape is in a shape of a box, therefore we are going to apply the formula for the box. Remember, the volume of a box is equal to LBH. Right, and then now remember, if you check at your units now, we have a challenge because this is in millimeters, whereas the rest is in centimeters. We need to deal with that millimeter. Moving from millimeter to centimeter, it's only 1 digit, it's from millimeter to centimeter. So we are applying 1/10 again. Therefore, we are going to, because it's small to big, we are going to divide by 10. So grade 12, this will be 60 millimeters divided by 10. And then if you divide by 10, it will give us 6. Then this 6 will now will be in centimeters. All right. And then now let's substitute now. This side now, we are going to use it as 6 centimeters. So we substitute, we have a 6, we have a 2, we have a 5 there. Remember our dimension, whether you say 265 or 652 or 526, you are still going to end up with the correct answer, grade 12. Right. And then now let's continue. Now you put everything into your calculator. 6 times 2 times 5. This will give you 60 cubic centimeters. Remember, if it's a volume, it will be a cubic unit. Therefore, it is cubic centimeters in this particular case. And then 2.2. Calculate the surface area of the sugar box now. Surface area, do you still remember? We are talking the top, the bottom of the container, the left, the right of the container, and then we are taking the front and the back from that side. Okay? And then if we break this off, you know, grade 12, we have dimensions for this side. Yes, 6 by 2. Do we have dimension for this part here, which is the front part? We have 5. Remember, this 6 will apply to all the sides throughout. They are equal. So yes, we do have is 5 by 6 there. Do we have the dimension for the top and bottom? Yes, we do have. That is 5 by 2. This front, back, left, right, it will 2 by 6. And then the front and the back, it will be 5 by 6. We have everything that we need. We can now calculate the surface area. That will be 2. Left and right, that is 6 by 2. Okay? Plus 2. Front and back, that will be 5 by 2. Therefore, it is 5 by 2 dimension. Plus 2. Top and bottom. Top and bottom. So we are talking to this dimension. That will be Top and bottom, we are having 2 by 5. Grade 12s, let's start again. We have left and right, that is 2 by 6, correct? Therefore, you are taking to this dimension. All right. And then we have front and back, that is 5 by 6, grade 12. Front and back, 5 by 6. Then we have top and bottom, that is 2 into 2 and 5. 2 and 5 from that one. And then into our calculator, straight to the answer, grade 12. We are having what? A 104. And then remember, our unit is in centimeter, but because it's an area, it will be a squared unit, which is squared centimeters in this particular case, grade 12. Okay, I hope we are still together on that one. Okay, let's see. What can we have for you as our last activity for the day? Let's move to the cylinder and have the last activity that you can do, grade 12, for me for the day on cylinder. Okay, this one we are given a cylindrical container that has a capacity of 440 and a radius of 4 centimeters. Determine the height of the cylindrical container and hence calculate the total surface area of the cylindrical container, grade 12. Please copy this question. This will be your homework activity, and then you can also ask your educator to assist you on that one, grade 12. Please copy the question. You have 3 minutes to copy that. Starting now, that is your homework. Okay, thank you very much, grade 12, for availing yourself for this particular lesson. Enjoy your Easter, and thank you very much also to your educators for ensuring that this lesson reaches you. This lesson was brought to you by Gauteng Department of Education in collaboration with Cybono Discovery, and then it was broadcasted by Pagama Research and Development. Till we meet again on our next presentation. Thank you very much. Bye.